Welcome. In this video, we're going to keep talking about the Pythagorean theorem. Specifically, the video lesson is focused on how do we find the distance on a coordinate plane. When you read our first objective today, you will see that's our big goal, exploring some more. How do we apply the Pythagorean theorem to find out how long line segments are on the graph? And that's what it says, determine distance on a coordinate plane. That just says how long are these diagonal lines when they're put on a graph. So let's take a look at the two examples we're going to work through today. They're a little bit more challenging. The main reason, you see for both part 1 and for part 2, the diagonal lines we're finding cut across a bunch of quadrants. It's more difficult now because we have negative numbers in the coordinates. So take your time to pause the video and right now just work on part 1. Can you find the length of line segment AC? And this table down here is set up to help you figure out what is the length of A to C. So pause the video, take a look. Welcome back. So I'm going to take a look at this, and there's two main ways I can attack a problem like this. Both of them involve having to first find the distance of A to B and the distance of B to C. Hopefully, I'm going to go ahead and afterwards we're going to fill the screen table out, but right now I'm going to open the drawing to take a look at what we need. Hopefully we recognize now that when you take a rectangle and split it diagonally, we have a right triangle. Anytime we build a right triangle on our graph, we can measure the sideways and the up and down legs by using the coordinates or by counting on the graph. I'm going to flip to the whiteboard so we can take notes as we're going here. And the first thing we're going to see up here, I want to take a look at what the coordinates are. So for A, if I know the coordinates for A and C, it makes my life a lot easier, like we're going to show later. So I'm going to go ahead. What are the coordinates for A? Hopefully you know the coordinates for A are -2 and 5. And while I'm typing that in, figure out what are the coordinates for C, the other point that we're finishing at. Hopefully on your own, you're recognizing that C has coordinates in X value. It is 7 to the right on the X-axis. And it is down by 3 units on the y-axis. So it has coordinates of 7 and -3. I'm going to go ahead and draw that out on our whiteboard a little bit here. We've got a right triangle here from A to B to C. And I know that A's coordinates, I'm going to write that here, A's coordinates, -2 and 5. B's coordinates, 7 and -3. I have two options to figure out how long A to B is at this point. Option number 1 to figure out how long A to B is just to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the distance from A to B is 9 units. I got that by counting up on the graph. The other thing I could have done, if we take a look at the whiteboard, an easier way to see that the distance from A to B, our sideways movement, is 9, is to see how much the X value changed by. For A, it starts out at -2. By the time we get to B, it's up to 7. So if we jump up by 2 to get to 0, and 7 more to get to +7, 2 plus 7 gives us 9. Let's take a look for B to C. First, again, I'm going to count. At my B, there's 1, 2, 3, 4, 5, 6, 7, 8. 8 units to get down from B to C. And again, we're going to take a look. An easier method than counting would be to use coordinates. The Y value up at point A and B is 5 units when we're up here. By the time we get down to C, we're down to -3 units. Let me show you that on the graph. C is at -3. B is at 5. So for me to get from +5 down to -3, I jump down by 5, 3 more. 5 plus 3, I traveled a total distance of 8 units to get from 5 to -3. You'll notice this is not negative. No side length can be negative. I traveled down by 8 units. That means the Y lost 8 units of value, but it still means this leg, if we had a triangle put on the graph, is +8 because you can't have a negative distance. Now that you know this is 8 and 9, pause the video again, find the missing side length. Welcome back. We're going to show you that hopefully this, once you have side lengths, most of you should be comfortable now. Set up a² + b² = c². Draw a line through your equation. That's called the river. It helps us keep track of where everything is at. A is going to become 9. B is going to become 8. C is the thing we don't know. I'm going to go ahead and call it line segment AC, and that's going to get squared too. 9 squared gives us 81. 8 squared gives us 64. Add those numbers up, 80 and 60 gives us 140. 1 and 4 gives us 5 more. So the side length for AC, or line segment AC, when you square it, has a value of 145. How do we get rid of that squared? We take a square root from both sides, because a square root will cancel that out. And now I know that AC is equal to whatever the square root of 145 is. So let's drop that work into our document.